Hi there everybody. Today we're going to look at geometric sequences. If you're not quite sure what geometric sequence is, it's like many other sequences, but the key part of this one is that whatever you're going to start with in terms of a number, we are going to multiply it by something, alright? So effectively I'm going to multiply by a constant from term to term to term to term, alright? Now don't expect necessarily that multiple has to be a positive whole number or a bigger number. It doesn't mean it's necessarily going to get bigger. It just means that I'm going to multiply it by something. So if I was going to times it by a fraction or a negative, then obviously that's going to have an impact in terms of what it looks like. But we are going to multiply it by a constant each time. Okay. Well, that multiple tends to be called a common ratio. All right, and that's the correct terminology for it, and that is often given the letter R. All right. Okay. So that's the nitty gritty of the termination. So if I asked you to find the common ratio of this particular one, well, the easiest way of doing this one, if you are told it's a geometric sequence, then literally the easiest thing to do is just take your first two terms and do the second one divided by the first one. All right, and that should be the same all the way through. So let's have a look. 12 divided by 3 is 4. All right, if I did 48 divided by 12, it's 4. And I'm sure that you know 768 divided by 192 is also 4. The answer, therefore, is 4. All right, I don't need to do the rest. Really, just take your second one and your first one. Certainly the smaller numbers are going to be easier because it's going to be common all the way through. And again, especially if you're told it's a geometric sequence and asked for the common ratio. Okay, so let's have a look at this one. A little bit different in terms of how it looks, but ultimately it should be the same process. Now, what I said to you do, you're going to do the second one divided by the first one. Now, looking at this one, it might not be as easy to think about it when I do that one divided by that one, but it will be the same on any of them. So it's probably easier to choose your smaller numbers. So if I take this one here, 2 divided by 10, well, 2 divided by 10 is 2/10. Simplified is 1/5, and therefore 0.2. Okay, so we can see from here on the sheet, they've gone for this one divided by this one because it's the same as this one divided by this one. But arguably, trying to find some easier numbers within there, 10 divided by 50, that's 1/5. And 2 divided by 10, like I said, is 2/10, which is 0.2. So there are easier ways of kind of doing it rather than picking the ones at the end. All right. So that's a common ratio. That's R. All right. The second part of geometric sequence is a little bit more than that. All right. So we're going to look at this aspect as well while we're here. So A tends to be given the letter for the first term. All right. And then R obviously is the common ratio, which we just kind of did literally 2 minutes ago. All right. So thinking about what that looks like, if you think about your first term is A, then you're going to times it by R, A times R. You're then going to times it by another R, so A times R, which is AR squared. And then the fourth one is going to be AR cubed, and so on and so on and so on. And it's going to keep going up by an additional value of R each time. All right. So there's a kind of formula to kind of put that together, which represents a geometric sequence, and it's given as this as AR is the n minus 1. Right, now your question might be, what's this n minus 1? What's this all about? Well, I'll explain that one. All right, so if you think about I'll take the third term here. All right, and the reason I'm mentioning the third term, what do you notice about this power? All right, it's 1 less than 3, isn't it? All right, so for my third term, it's 1 less. For my fourth term, it's 3. It's always 1 less, isn't it? All right. For my second term, and what's probably missing here is a little 1. All right. For my second term, it's just 1 lot out of R, isn't it? And then my first term, well, there's no R's. Is there? There's none. All right. So there's always kind of 1 less. So hence what that notation is talking about is A, and then times it by however many R's there are, depending on term. So if I wanted the fifth term, for example, which is not on here, it would be A times R to the power 4. All right, 1 less. Okay, so let's have a look. So let's say that you're given your first value and your common ratio is 5. So that means you're going to take 4 and you're going to multiply by 5 each time, again and again and again and again. So your numbers are going to go up pretty fast, all right? But maybe that's just what the third one is. All right, now you could go through every single one of these quite comfortably. So let's have a think about what the first one is. So A is 4, so times it by 5, it's going to give you 20. And then times it by 5 again, that's going to give you 100, isn't it, when I go through that process. However, if I use the third term and I relate it to this bit here, so that's the third one. So remember, it's 1 less. So a times r squared. All right, well, r squared is 25. Times it by 4, and that's going to give me 100. All right, and I guess that's what it's probably going to do here. So here you can see the notation being used. You've got a times r times n minus 1. All right, so squared. All right, 1 less. Okay, so they've used this formula this time to kind of show you. All right, so it's going to be 100, which, like we said. Okay, right. But the idea of counting up, obviously, is going to be quite hard. So hence they really would expect you to kind of apply this. So the 8th term, and hopefully you can probably guess before I kind of say it, is going to be a times r to the 7. All right, so it's going to be 1 less. All right, so let's see that kind of written in. There you go. So a times r to the 7. So 4 times 5 to the power 7. And I don't expect you to know what 5 to the power 7 is. I don't know what the 5 to the power 7 is, but then I'm going to times it by 4. All right, so there you go. 312,500. All right, so that's how we do it. Okay, let's look at a slightly different example. In that maybe they don't give you a and r, maybe they just give you the sequence. All right, and from this you've got to decide first of all what a is, what r is, and then from there use the formula which we've just kind of gone through. All right, so first steps first. What is the first digit? What is the first number? What is the first term? Well, it's 6, isn't it? So a is going to be 6. All right, and then what I'm looking at is, well, what's the common ratio? All right, so I'm looking at this one divided by this one because they're the smallest numbers. Or what's 12 divided by 6? It's 2. All right, so you can see that kind of done from there. So 12 divided by 6 is 2. So we've got a and we've got r. Now, if I want my 11th term, now I'm going to apply the formula which I've just kind of given above it. So it's going to be a times r to the 10 because it's 1 less. All right, so that's going to be 6 times 2 to the power 10. All right, so let's see that written down. So 6 times 2 to the power 10. Now, again, not really sure what's 2 to the power 10 at the top of my head. Could have a guess, but then I'm going to times it by 6. So let's just kind of see what it is. So 6,144 is going to be your solution to that one. By all means, kind of check that, but I'll trust that that's right. Okay, so that's the geometric sequence, and that's the kind of formula kind of used. All right, so A represents the first term, and R is your common ratio, and obviously from there you've seen how that comes together, and any term given is using that little formula there. All right, so try and get on top of it. Okay, so for a bit more practice, please visit maths-school.co.uk. There is a link at the bottom of the page for you to kind of have a look at, and there's obviously a bunch of questions on there for you to kind of practice. All right, well, thanks for listening.